Hello guys, welcome back to our channel Geomatics Engineering. Here we learn and explore the things related to geomatics engineering. So in this video, we are going to see angular measurement using compass surveying. So before starting our angular measurement portion, I will talk about linear measurement. A little discussion we will do because linear measurement is not in our syllabus in deep. We will have to just see what is linear measurement and what is methods of linear measurement. So linear measurement. If we are doing measurement along a straight line, if we are doing measurement along a straight line, for example, measuring distance in a horizontal plane, then the measurement is called linear measurement. So there are several ways of doing measurement, linear measurement. For example, pacing, manual counting of your pace. Then there is a example pesometer. In this, a clock like device is taken into the pocket. This clock device just automatically measure the your counting of pace by motion of your legs. So this is automatic counting of your pace. Then pedometer does what? It is a kind of pesometer, but it measure the pace and then multiply a average distance assumed by it, so that you will get a whole distance in your result. Then odometer takes help of velocity and time. Then chaining is mostly used in surveying. Chaining with help of chain or tape is mostly used in surveying for linear measurement. So this is not in our syllabus in GATE Geomatics Engineering syllabus, but it comes in civil engineering syllabus. So if any one of you from civil engineering background wants me to talk about chain surveying and corrections in chain surveying, then just let me know into the comment box. Also mail me, then I will think and I will make a separate video on chaining also. So now next is indirect method of measurement. There is optical method, which is also known as tachometry. Then there is electronic distance measuring method, in which with help of radiations we measure the distance. So this much a little introduction of linear measurement we have to know. Now moving towards angular measurement. So what is angular measurement? In angular measurement, points we establish point or we measure the point more accurately with help of angular measurement. How? For example, this is our point C and we have a line AB. We have a line AB. So along with our linear measurement, if we will measure this angle also, then we will get precise position of C. So in this way, angular measurement works. For example, there are several ways of doing angular measurement. There is theodolite for it, theodolite. There is compass for it. In this video, we will talk about compass surveying and how to use compass surveying for angular measurement. Now, for angular measurement, we need a reference line. For example, in this example, this AB is the reference line. This AB is the reference line. And with help of this reference line, we measure the angle. In our surveying portion, this reference line is known as meridian, and this angle measured is known as bearing. So from now I will talk in terms of meridian and bearing only. Now moving further, what are the types of meridian? So let's see it. We know that our earth is not completely spherical or ellipsoidal. So let's see, our earth is like this only. Our earth is like this only. If we will talk about that this point is true north, if we will see this point is true north, actual north point of the earth, and this point is true south, actual south point of the earth, then imaginary line that passes through these 2 points, is known as true meridian. Means we can say that imaginary line joining true north and true south of earth is known as true meridian. So these 2 points are fixed on the earth, so these point never changes, these points never changes, but it is very difficult to establish over it earth surface. It is very difficult to establish over it earth surface. And the angle measured with help of this meridian, true meridian, is known as true bearing. So just keep it in mind that what is true meridian, and the angle measured with help of this meridian is known as true bearing. Now moving further, next one is our magnetic meridian. We know that our earth is consist of several minerals. It consists of several minerals. And also we know that if any electron moves with certain speed or moves with certain rotation, then it generates magnetic field around it. We know that if any electron or particle moves with certain speed or accelerates, then it generates electric field, magnetic field around it. So in this way, our earth consists of several minerals. And it also revolves and rotate. So because of this revolution and rotation, it also generates magnetic meridian, magnetic field like this, what we have drawn here. Like this, it also generates magnetic field. But this magnetic field does not passes through true north and true south. This passes through something other imaginary line, some other imaginary line it passes through, and that imaginary line is known as magnetic meridian, So this is about magnetic meridian. What is the magnetic meridian? And here we near the true north we called it magnetic north, near the true south we called it magnetic south. So this is our magnetic meridian, and with help of this meridian, if we will measure any angle, that will be our magnetic bearing. So this is clear, and we should know that our compass which we use, it aligns itself to the direction of magnetic field generated by these minerals. So in our case, we measure magnetic bearing only with help of magnetic compass. We measure magnetic bear only, not true bearing. But the scene is that this true bearing and this magnetic bearing changes over time. This changes its position. Because of revolution and rotation, this changes position. It is not fixed. So we will see that also. We will see numericals over these magnetic meridian and true meridian. Now moving further, the third one is arbitrary meridian. For example, you don't have magnetic compass or anything. You don't know what is your true meridian and what is your magnetic meridian. So for example, you have a building nearby, or you have a field nearby your point. C. So you will take this side as your reference. For example, this is a field, and you will take this side of your field as your reference. So random chosen line for your measurement is known as arbitrary. The random chosen line for your measurement is known as arbitrary meridian. This line is chosen as a measurement for measurement purpose, and we will measure this point and this angle with help of this line. So this line is known as arbitrary meridian, and this angle will be known as arbitrary bearing. So it is like this only. For relative measurement, we took arbitrary meridian. So this is about what are the types of meridian. Now moving further, let's see how we measure bearings. There are two systems of measuring bearings. Let's talk about them one by one. The first one is whole circle bearing system. The whole circle bearing system. Let's see how we measure angle in these bearing system. For example, this is our north and south line. This is our east and west and east line. Okay. If we have certain line over here, if we have certain line over here, for example line A, B, if we have certain line over here in our north, south, east, west, so in whole circle bearing what we do, we always measure angle of the line from north. Consider this, we always measure angle of the line from north, and from north we move in clockwise direction. We move in clockwise direction and then measure the angle. And that angle is known as bearing, and this angle considered in the whole circle bearing. So for example, this line is like this, so we are measuring this angle. Theta will be something more than 90 degree. It can be like this also, some line it can be like this also. So here the theta will be what? Here theta will be 90, 180, 270, more than 270 degree. And also sometimes it line can be aligned in the north direction also, so it can reach up to 360 degree also. So the range of theta value here is from 0 to 360 degree. Means we are completing a whole circle. That's why it is named as whole circle bearing system. Now next one is quadrantal bearing system. What we do in quadrantal bearing system, let's see that. For example, again I am making north and south, east and west. For example, this is our north, south, east, west. In this case of measurement, quadrantal bearing, for example, this is our line, this is our line 1 AB, and this is our next line, for example AC. Okay, this is our line A, B and C. We have to measure the bearings. In this case, we can measure from north also, we can measure from south also. It depends upon us. We have to see just that line is nearer from north or nearer from south. For this case, it is nearer from south, so we will measure from south. It is nearer from north, we can measure in from north. And also we can move in clockwise direction and anti-clockwise direction, both, which is suitable, which gives us acute angle. We will do that. For example, for AB, we will measure from south and we will move in anti-clockwise direction like this, and we will say it alpha. Alpha is our angle. And for line AC, we will move from north and we will move in anti-clockwise direction like this, and beta. And how we will represent this angle? We will represent like, for example, this one, bearing of AB. We will represent, we have started from south, so we will write down south. We have moved alpha angle, so we will write down alpha. And we have moved toward the east, so we will write down east. So this is the bearing. And for AC, we will write down north. We have started from north. We will write down the angle value beta, and then we have moved toward west, so we will write down west. So in this way this thing works. Now I am concluding this two system. In this system, always measurement is done from north direction only, north direction only. Here north or south, whichever is near, whichever is nearer. Now next thing, in this system we can move only in clockwise direction, only. And here clockwise and anti-clockwise both, clockwise or anti-clockwise, which will give acute angle. Next one, the range of or the representation is like this, theta only, and the range of this theta is 0 degree to 360 degree. And here how we represent like north theta east, or north theta west, or south theta east, or south theta west. And the range of theta here is only 0 degree to 90 degree. So in this way these two bearing system works. These two bearing system are interconvertible into each other. Just note that if question comes in such a way that this bearing in this system is given and this system is asked, or this system is given and this system asked, just note that first make the figure and plot the line there, you will see the bearing by just making the figure and plotting the line there only. So just keep in mind that if any type of question came like conversion of bearing, so make the figure. So this is about system of bearing. Now moving further, types of bearing. So on the basis of propagation of survey line, there are two types of bearing system. One is fore bearing, another one is back bearing. Let's understand what is this. For example, this is our line system. This is our line system, A, B, C, D. And this is our line propagation from A to B, then B to C, and then C to D. Okay, if I will make meridian here, I will take our compass, measure the meridian where it is pointing north and south, and then I will measure the bearing of line AB. So this will be called bearing measured in the direction of line. Direction is this, and bearing is measured from A to B. So bearing measured from direction of line. Bearing from A to B measured. So it is in the direction of line. So if bearing measured in the direction of line, then it is called fore bearing. If bearing measured in the direction of, and for example line AB is given, means from A to B bearing is measured, then it is called fore bearing. And just opposite, if bearing measured opposite to the direction of line or propagation of line, then it is called back bearing. For example, if I will measure bearing of line AB from B and the direction of propagation is A to B, and I am measuring the line bearing B to A, this one I am measuring, then it is called back bearing. For example, it is A, it is B. Here A is fore bearing and B is back bearing. Bearing means angle, and I am measuring angle in the direction of line, then angle, it is called fore bearing, and I am measuring angle in the opposite direction of line, then it is called back bearing. So Just in this way, remember this, what is forward bearing and back bearing. It is very useful in calculating out included angles. We will see what is included angles, deflection angles, etc. So these are very useful, forward bearing and back bearing. Also, forward bearing and back bearing give us check regarding our measurement is right or wrong. We will see how. For example, let's see, this is our line AB. This is our line AB. This is our line AB. I am making a meridian here. So this is our line AB and this is our meridian north and south. So I have measured in the direction of line AB, A to B. So this angle is a mine alpha and alpha is mine 4 bearing. Okay. Now again from B I am making meridian. I am measuring now angle from B, that is in the opposite direction. So this one is my angle from B in the opposite direction. This is my back bearing. Okay, beta. So do you know alternate opposite angles or alternate interior angles? This north south is parallel to this north south, we know that, and between parallel line this is another one line. So if this angle is alpha, so I can say this angle will be alpha also. What is called it? Alternate opposite angle. So this is alpha, so this is alpha also. And then if we will subtract this beta and alpha, then if we will take difference of this beta and alpha, then we will get the angle, this one, and this one is 180 degree. So we can say if our measurements are correct, then difference between forward bearing and back bearing is 180 degree. So it gives us a check that our measurement is correct or not. So forward bearing minus back bearing, or vice versa, back bearing minus forward bearing, must equal to 180 degree. Okay, so it is a check for us that our measurement is right or wrong. Now moving further, that is magnetic declination. Let's see what is magnetic declination. We know that our true north and true south are fixed. So I am fixing a true north and true south here. Okay, this is our true meridian. True north, true south, true west, true east. So with respect to true north, I am talking about with respect to true north, our magnetic meridian is like this only. For example, our magnetic meridian is like this only. Okay, this is our magnetic north, magnetic south. So this is our magnetic meridian. So the difference or we can say the horizontal angle between these two meridians, the horizontal angle between these two meridians is known as declination. The horizontal angle between these two meridians is known as declination. If magnetic north is in the east direction of the true north, If magnetic north is in the east direction of the true north, then this declination is taken as positive. Positive. Write down. I am saying it. Pause the video and write down because it is very useful. If what I have said again, I am repeating. If magnetic north is in the direction of east with respect to true north, if magnetic north in the direction of east, in the direction of east with respect to true north, then it is taken as positive. Otherwise, for example, if our magnetic north in the direction of west, if our magnetic north is in the direction of west with respect to true north, for example beta, if our magnetic north in the direction of west with respect to true north, then it is taken as negative. Means here beta is negative and alpha is positive. So there are two types of declination, that is positive declination and negative declination. And with help of these two declination, we can calculate true north, true meridian, magnetic meridian. From true meridian we can calculate magnetic meridian. From magnetic meridian we can calculate true meridian. So this type of question also comes. So we have to just see, we have to again make the figure only and then check what is the declination given and what is the magnetic bearing all given there, and with help of those bearing we can calculate out true bearings. So in this way questions came. We will see the questions also in our next video. Just see that our magnetic declination is due to several reasons, that is daily variation due to rotation of earth, then annular variation due to revolution of earth, variation in a year, secular variation, this is because of more very long with a variation which took very long time, for example 150 to 300 years, variation in 150 to 300 years. Then irregular variation, also we can say it as an accidental variation because of some disaster like earthquake, cyclones, anything. So these disaster calls irregular variation. And with help of magnetic declination, two terms are there, that is isogonic line or agonic line. Just keep in mind that isogonic lines are the imaginary lines which are having same declination. For example, if I am having point here, it is having declination 10 degree, for example 10 degree. Again I am having point here, it is also having declination of 10 degree toward east, and I am matching these points which are having 10 degree declination. So this is called isogonic lines. But agonic line is also a kind of isogonal line, just the magnetic declination value is here 0. So keep it in mind only that what is isogonic line and agonic line, maybe it will ask. Next and last, that is local attraction. What happens in angular measurement if we will take compass and move to some place? If we will take compass and move to some place, in compass only magnetic needle, magnetic north and south needle is given. So we will see that this needle will vibrate too much if we will take it near a electric pole or what we call it a railway line. So it will vibrate too much, it will move frequently, and due to this vibration or this deviation our reading get error. Due to this vibration, this uh, deviation, our reading get error. This error is called as error due to local attraction. It is a local property, it is hence it is called as error due to local attraction. It is because of electric wire, railway track, iron ore below the earth surface, mineral content, etc. Several reasons are there. It varies from place to place, and there are some various technique to remove this local attraction. We will see in next video. Also we will see how we can measure the included angle and deflection angle using these magnetic bearings, and how we can remove the errors caused by local attractions and errors caused by users also. So this is all from my side in this video. That is, what is angular measurement, what are the types of measurement we are doing, what are the bearings, what are the meridians, types of meridians. That's all from my side in this video. If you are having any type of queries, then let me know. And if you are new to our channel, then please subscribe. We are seeing that many people just watch the video and don't subscribe to our channel. We have several plans for upcoming days, so if you will subscribe our channel, and also if you have subscribed to this channel, then share it to your friends and family, so that we can get a boost up, we can reach a milestone of YouTube. And also we are waiting for 1000 subscribers, so that we can have community post also in YouTube. Before 1000, YouTube will not give us rights to have community post. So just share us, make our channel grow. This is all we want from you. So thank you from my side, and we will meet in next video. See ya.